Hello, I'm Tim, and today I'm going to talk about sequences and their applications in the real world. So first of all, we need to define what a sequence is. So a sequence is an ordered collection of numbers, where the word ordered here is really important. It means if I have the sequence 1 minus 1, 1 minus 1, and so on, that isn't the same as the sequence that goes minus 1, 1, minus 1, 1. They're different. It means that the order of the terms really matters. There are three main types of sequences, and we're going to look at each case. The first is arithmetic. These have a general formula of an is equal to a plus n minus 1 times d, where a is the first term and d is the common difference. This means these sequences all have a common difference between the terms. So for example, if we looked at the sequence 4, 7, 10, 13, this will have a general formula of 4 plus 3 lots of n minus 1. The second are geometric progressions. These have a general rule of an is equal to a times r to the n minus 1, where again a is the first term and now r is the common ratio. So for example, we have the sequence 1, a half, a quarter, an eighth. This will have a general rule of an is equal to 1 over 2 to the n minus 1. The final sequence we're going to look at is recurring sequences. So this is where the new term is defined directly in the terms of the previous ones. So for example, we could have an is equal to an minus 1 squared plus 1. We'll look at an example of these types of sequences at the end of the video. But before we do that, we're just going to discuss why sequences are important. So why do we study sequences? We're just going to look at each case separately and give a couple of ideas. So arithmetic sequences, they can be used to work out your salary in any number of years, and also how much of something I need to sell to make a profit. For geometric sequences, I can use them in interest rates. So if I had to take out a loan, I could work out the total amount of money I'd need to pay back. And I can also model population growth using geometric sequences. For recurring sequences, I can use mathematical models and algorithms. These turn real-world problems into mathematical ones, and then I'm trying to solve them. These are by no means the only applications, but it gives you an idea of where sequences can be used. To finish, we're just going to look at one example of a recurring sequence. This is the Fibonacci sequence. It was first studied by Indian mathematicians, but it gets its name from the Italian mathematician who was interested in how pairs of rabbits would evolve over time. This has a general rule where I take the previous two terms, I add them together, and I get the next term in the sequence. This sequence has a lot of interesting applications in its own right, and a lot of research goes into it. But we're going to look at a slightly different sequence, which is fn plus 1 over fn. So this sequence goes 1, 2, 1.5, 1.6, 1.625. You can actually show that this tends to the number 1 plus root 5 over 2, which is approximately equal to 1.618. And we're going to call this number phi. So why are we interested in this number phi? Well, it's all to do with the so-called golden ratio. Two numbers, a and b, are said to be in a golden ratio if we have the a plus b over a is equal to a over b, and then that is equal to phi. So from what we've shown, we can see that the Fibonacci numbers satisfy this. We can also see this from the following picture. If we let the size of the squares go up in terms of the Fibonacci numbers, then we can see again that this satisfies this spiral. And this, in fact, is really important in modern day life. A lot of objects which are seen to be beautiful, so it might be buildings, people's paintings, all of these seem to satisfy this ratio, this golden ratio. So architects often use this ratio to try and construct buildings so they look beautiful. We hope you found this video interesting and have learned something about sequences and their applications in daily life. Thank you for watching.